Hello friends, my name is Tushar and today we're going to talk about Z algorithm for pattern matching. In another video, I already talked about KNP algorithm for pattern matching. In this video, we're going to look at Z algorithm, which has similar time complexity as KNP algorithm. The core of Z algorithm is this function zk, where we are trying to find the longest substring starting at position k, which is also the prefix of the string. Let's try to understand what this means with the help of this example here. So I have an array Z and I'm trying to find the longest substring, which is also the prefix. So Z of 0, what we store at 0 is not important, so Z of 0 will just store 0. And then we are going to start with Z of 1. So at 1, we're trying to find the substring starting from position 1, which is also the prefix of this, string. So basically I'm comparing this A with this A and both of them are same. So we're going to move by 1 and then we try to compare this A with this B and they're not same. So we'll put 1 here. So what this 1 means is there is a substring starting at position 1 which is also the prefix of this string. So then we move to 2. So now we're trying to calculate Z of 2. So this, we are trying to compare this B with this A and they are not same. So this value is 0. Then we try to compare this X with this A and they are not same. So this value is also 0. Then we're going to compare this A with this A and they are same. And so we compare this A with this A and that is same. And then we compare this B with this Y and they are not same. So we get value 2. So basically at this position, there is a substring of length 2 starting at position 4, which is also the prefix. So this A is also the prefix. Then we go here, so we compare this A with this A, that is same, and then this A and this Y, that is not same. So this value is 1. And then this Y and this A is not same, so this is 0. So then we come here, this A and this A is same, this A and this A is matches, and this B and this B matches. So we get a length 3 here. Then moving to the 8th position, this A and this A is same, this A and this B is not same, so this is 1. And then finally this B and this A is not same, so this is 0. So hopefully this helps you understand what this function Z of k means. So in the next section, let's see how we use this information for pattern matching, and later on we'll see how we can create this Z array efficiently. Here my text is this and my pattern is ABC. And I'm trying to find all the indices in this text where this pattern exists. So this pattern exists at this point and this point. So the way we use Z algorithm is, first we combine this pattern and text into one long string and separate them by a special character which doesn't exist in either of those strings. So ABC, dollar, the special character, and then rest of the text. Now I'm going to calculate the Z function, Z array for this long string. So let's do that. So value at position 0 is not important, so I'm just going to put a value 0. So now I'm going to compare this B and this A and that is not same, so this is 0. I'm going to compare this C and this A, it's not same, 0. Dollar and A is not same, so this is 0. This X and A is not same, so this is 0. This A is same as this A, this B is same as this B, this C is same as this C, this dollar is not same as A, so this is 3. Then this B is not same as this A, so 0. This C is not same as this A, so 0. This A is same as this A, this B is same as this B, C and Z is not same, so 2. Then 0, 0. This A is same as this A, this B is same as this B, this 3 and this C is a match, so 3 and 0, 0. So once I'm done creating my Z array, I'm going to look for the positions where the value is same as the length of the pattern. So the length of the pattern is 3. So I'm looking for 3 in this array. So I find 2 3s at this position and at this position. So what I'm saying is that at this position the text, the pattern exists in the text. Why? Because at this position there is a substring of length 3 which is also the prefix. So this 3 is same as this 3. Also I know that my pattern of length, my prefix is here is my pattern. And so this 3 here must be a match with this 3, which is why this pattern exists at this position. Similarly for this guy, there is a substring of length 3, which is also prefix. So this 3 must be same as this 3, and we also know that this 3 is my original pattern. So this pattern must be existing at this point here. So now how do we know that at which index they exist in the text? So in this long string they exist at index 5 and they exist at index 11. So to get the index in the text, what we have to do is we have to subtract the length of the pattern plus this special character, so 4 from this number. So we subtract 4 from 5, so we're left with 1, and we subtract 4 from 11, so we're left with 7. So in the original string, my pattern exists at position 1 and 7. So if we go here 0, 1, so pattern exists at this point, then 2, 3, 4, 5, 6, 7. So pattern also exists at that point. So now the only thing left is to show how we can create this Z array efficiently in O of m plus n time. Let's try to calculate the Z array for this string here, and also to show that this is happening in linear time, let's keep the count of number of comparisons I'm doing. So Z of 0 is not important, so we'll put a value 0 and we'll start from 1. So this A is same as this A, so that's a match, and this A is not same as this B. So we did 2 comparisons and we'll put a value 1 here, saying that there is a substring of length 1 at 1 which is also prefix. Then this B is not same as this A, so we'll put a value 0 and we did 1 more comparison. This X is not same as this A, so this will be 0 and we did 1 more comparison. This A is same as this A and this A is a match, this B and B is a match, X and X is a match, A and C is not a match. So we did 5 comparisons, 1, 2, 3, 4, 5, and we put a value 4 here. So here I have my Z box. This is the left end of this Z box and this is the right end of this Z box. Now my aim is to do as few comparisons as possible in this Z box. So what do we know is that there is a substring of length 4 which is also a prefix. So this AABX must be same as this AABX. Also we have calculated the Z values of this AABX100. So our idea is, why not just use those values here? So instead of trying to do comparison for A, B and X, we can just use these values 100 right here. And this is it. So we would only need further comparisons if this value was large enough such that it touched the right bound from here. So if this value was 3, and so if we add this 3 to 5, this value would exceed this right bound, and in that case we would have to do further comparison, and we'll see in this future in the string how that works. But at this point of time I did not do any other comparisons. I just copied this 100 here because this ABX and this ABX is same. So now we'll continue from C. So this C and this A is not same, so we did 1 more comparison and this value is 0. This A and this A is same, this A and this A is match, this B is a match, X is a match, A is a match, A is a match, B is a match, X is a match, and C and A is not a match. So from here to here we did 1, 2, 3, 4, 5, 6, 7, 8 and 9 comparisons. So 1, 2, 3, 4, 5, 6, 7, 8, 9 comparison. Let's draw the Z box here. This is my left and this is my right of the Z box. Now I know that this 8, there is a substring of length 8 which is also the prefix. So going from here to here. Now again, just like before, my idea is not to do any more comparisons for all the characters in this box, but try to use the values which I have already calculated before. So let's do that. So since this is same as this should have a value 1, then this should have a value 0, then this should have a value 0. What about this guy? Is this a value 4? Let's see. So as I said before, there's a caveat that if whatever value is here plus whatever value we can get from its corresponding in the prefix, corresponding position in the prefix, if 13 plus 4 touches my right bound, so 13 plus 4 is 17, which is beyond my right bound. In that case, we will have to do further comparisons. So first thing we are going to do is move my left bound to this point here. So this is the start of my left bound, and now I'm going to do further comparisons from here onwards. So we already know that there must be a substring of length 4, which is also a prefix. So these 4 characters are already matched. These 4 characters are already matched for at this position, and I need to do further comparisons. So then I'm going to check the 5th character from here with this guy, and both of them are same. Then I'm going to do A with Y, and that is not same. So I did 2 more comparisons, and I found out that the length of the substring, which is also a prefix, is 5, because we had one more match with A. So now my Z box is here to here. Now in this Z box, our aim is to do as few comparisons as possible. So this 5 must be same as this 5. And we have already done the calculation for this 5, so let's try to use them here. So 1 will go here directly because 1 plus 14 does not touch the right boundary. Then 0 and 0 will go here directly. What about this 4? Can this 4 go here directly? No. So what we are guaranteed is whatever the difference of this guy from the right bound is, we will at least have that many characters. So we'll at least have one character here, one value here, and we have to do further matching. So at this point of time, I'm going to compare my Y with my second character. So I know that there is at least one guy, there is at least a substring of length 1 here, which is also the prefix. So this A and this A we have already matched. And now we're going to try to match this A with this Y, and that is not same. So we did one more comparison, and this value finally stayed at 1. Now we move on to the last character. So this Y is not same as this A. So we put a value 0, and we did one more comparison. So here, in total, I did 5, 10, 15, 20, 23 comparisons in a string of length 19. So again, this string will be the combination of pattern plus dollar plus text, and the total length of this string will be O of m plus n. And we saw that we can do linear number of comparisons to generate this Z array. So basically I'm saying is that we can generate this Z array in O of m plus n time complexity. And the space complexity for this algorithm will be also O of m plus n. So in the next section, let's look at the code for this algorithm. The function is match pattern. It takes in a text and pattern, and it returns the list of indices at which this pattern exists in the text. So as we discussed in the video, first we create a new string whose length is the length of the text plus length of the pattern plus 1. Then we're going to add the characters of the pattern one by one into this new string, and then we're going to add the special character dollar into this new string, which separates the text and the pattern and the text, and then we're going to add the characters of text into this new string. So, and then I'm going to call this function calculate z with this new string, which is going to return me the z array calculated, and we're going to look at this calculate z function later on. Then I'm going to iterate through this z array and look for the locations where the value at the z array is same as the pattern length as we discussed before. And if I do find those guys, then all I do is add them into this result, and the index in the text will be I minus the length of pattern minus 1 as we discussed before in the video, and then ultimately I return this result. So next, let's look at how this calculate z works. The calculate z function, it takes in char input array and returns an z array of the same size as input. First thing we do is we initialize our z array, then we set up our left and right to be 0, which is the left and right bound of my z array, and then as we discussed before in the video, the value at z position is not important, so I'm going to put value 0 here,
and then we're going to start with k is equal to 1. So k is 1. Then if k is greater than right, it is going to be greater than right because right is 0 at this point of time. So we're going to say left is equal to right is equal to k. So our left will become 1 and then our right will become 1. And then while right is less than input.length, so basically checking that right has not going out of bound for the input array, and input of right is equal to input of right minus left. So right at this point of time is 1, and then right minus left, since right and left both are 1, right minus left will be 0. So what we're doing is we're effectively comparing value at index 1 and index 0. So we're comparing A with B, and that is not same. So we immediately break out of this while loop and we put k is equal to right minus z of k is equal to right minus left. So we put 0 in z of k, and then we do right minus minus, so value of right becomes 0. Then we go back to the top of the for loop. Now my k becomes 2. Now 2 is greater than right, which is 0, so we again go into this if condition, and this time my left becomes 2 and then my right becomes 2. And then we again do the same check. So right is less than input.length, yes, and input of right is equal to input of right minus left. So here right is 2, so right is A, so we're comparing this value at index 2, this A, with this A here, and both of them are same, so we do right plus plus. So value of right becomes 3. So at that point we is comparing input of right, which is 3, with right minus left, which is 1. So at that point we're comparing this x with this b. At this point of time they are not same, so we break out of the while loop, and then z of k is equal to right minus left. So we store 1 here. So basically saying that at index 2 there is a substring of length 1, which is also a prefix, this a, which is also the prefix, and then we do right minus minus, so right becomes 2. Then I'm going to go back to the top of the for loop. My k becomes 3. So k is 3, which is greater than 2, yes. So again we go into this if condition. So right is equal to left, left is equal to right is equal to k. So left becomes 3 and right becomes 3. Then we're going to checking right is less than input.length, it is, and then input of right is equal to input of right minus left. So then we are going to comparing this x here with this a here, and they're not same. So basically we break out of this while loop and we store 0 at z of 3, and then we do right minus minus, so right becomes 2. So again we go back to the top of the for loop, and then k becomes 4. Now 4 is greater than 2, so we again go into this if condition. So we say left is equal to 4 and right is equal to 4. And then while right is less than input.length, it is true, and input of right is equal to input of right minus left. So my input of right is 4 and right minus left is 0. So basically I'm comparing this a here with this a. So I'm comparing index 4 with index 0, and both of them are same. So we do right plus plus, so value of right becomes 5. So now I'm comparing input of right, which is 5, with input of right minus left, which is 1. So I'm comparing this b with this b here, and both of them are still same. So I increment my right by 1 more, so right becomes 6. Now I'm comparing this a at index 6 with this a at index 2, and both of them are still same. So my right becomes 7. And now I'm comparing this b here at index 7 with this x, which is at index 3, because my left is 4 and my right is 7, so 7 minus 4 is 3. So I'm comparing b with x, and this time it's not same, so we break out of this while loop and we go to z of k, and there we're going to store right minus left. So right is 7, left is 4, so we're going to store 3 here. Basically saying that there is a substring of length 3 at index 4, which is also prefix. Also our z box will look something like this now. So this is my left end of the z box, and this is the right bound of the z box here. Then we do right minus minus, so right becomes 6. And then we go back to the top of the for loop. Now my I becomes 5. So here our aim is to not recalculate the value for character, if possible not recalculate the values for characters in this z box, but just copy it from here, because we have already calculated for the first 3. So let's see if we can copy 0, 0, 0, 1 here. So k is now my k is 5 and right is 6. So k is not greater than right. So we go into this else condition. So I calculate k1. k1 is equal to k minus left. So my left is 4 and my k is 5. So my k1 becomes 1. So basically my k1 becomes 1, and now I'm checking if z of k1 is less than right minus k1 plus 1. So basically checking if the value at k1, which is 0, does it touches the right boundary of this z box. So if you consider 0 here, does this 0 from b, does it touch the right boundary? So it does not. So we go into this if condition and just copy z of k1 into z of k. So whatever value is stored at here at position 1, we just copy directly into position 5. So this takes value 0. Then we're going to go back to the top of the for loop, increment over k by 1 more. So k becomes 6. And then we again say that right is still 6. So we don't go into this if condition. We come to this else condition. So now my k1 becomes k minus left. So my k1 becomes 2. So now I'm trying to copy the value of z of 2 at z of 6, and let's see if it's possible or not. So at z of 6, we will have, if we consider this 1 here, this 1 does touch the boundary of the right end, because right end of this z box is right here. So we cannot just copy that value here. So what we're going to do is we have to first compare and see if there are future matches. So we do not go into this if condition because they are touching the boundary. So we go into this else condition. So my new z box is right here, starting from this A. Its left end is this and right end is this. So my left becomes k, which is 6, and I'm checking while input of right is less than this and input of right is equal to input of right minus left. So I'm checking, comparing this A with this. I'm comparing this A with this A, and both of them are same. So I do right plus plus. So at this point of time, my right becomes 7. Then I'm comparing this B here with this B here, and both of them are still same. So I do right plus plus. So right becomes 8. At this point of time, right is not less than input dot length minus input of length. So we break out of this while condition, and we say z of k is equal to right minus left. So z of k becomes 8 minus, and this left was 6. So z of k becomes 8 minus 6. So z of k becomes 2. And then we go again out of this for loop and go back to the top of this for loop, and now my k becomes finally becomes the last element, which is 7. And before that I decremented my right minus minus, so right becomes 7 again. So again, we don't go into this if condition because 7 is not greater than 7. We come to this else condition. K1 is equal to k minus left, so k1 is 1. So this k1 becomes 1, and we are checking if it is inside the boundary of this z or not. So now our z is this last two elements, and it is inside that boundary. So we just copy the value at z of k of 1, which is 0, right here. So, and then we go back to the top of for loop, and then k reaches the end of the input length. So we break out of this for loop and return this z array. So this is our z array, which is created in O of m plus n time. So this is all I have to talk about Z algorithm. Please like this video, comment on this video, share this video, check out my Facebook page, facebook.com Tushar25, and check out my GitHub link, github.com Mission Peace Interview Wiki. The link to this code is in the description section of the video. Thanks again for watching this video.